at so far is like, grab a pen, is like y equals 1 over x plus 3. Let's say it's like this, right? Does this have any points of discontinuity? Are any factors canceling off? No, so no points of discontinuity. This is just going to give me a what? An NPV, so a vertical asymptote. At what? At x equals -3. And a horizontal asymptote? At what? Y equals 0. Why?
It's the degree of x denominator is greater than that.
Yes, the degree of the denominator is degree 1, the numerator is degree 0. If the degree of the numerator is smaller than the denominator, you always get y equals 0. And like I told you, it's a rule right now, but in calculus, we'll actually understand why, which is next week. We start limits, which will make this make sense. Which makes you ahead of the game when you come to a diploma, but hopefully not answering it as a limit. They'll be like, where is this kid doing this? All right. Then we had ones where it was like x plus 2 over x plus 3. We'll say 3x plus 2 over x plus 3. Still just irrational. Is there any points of discontinuity on this one? No, because you would need to actually have larger than degree 1 to have a point of discontinuity, right? If not, it would completely cancel off and be like a line. So here we would get our vertical asymptote again. It's the same one. And it's at x equals -3. And then what would my horizontal asymptote be at this time? Why?
That's the numerator's only coefficient, not the denominator.
Right. If they're the same degree, you take the leading coefficients, the numbers that are in front, make a fraction, so we get y equals 3. This is true. Okay? Then we have y equals, say it factors, and we get x plus 3, x minus 2, over x minus 4, x minus 2. What degree is the top and the bottom on these ones? It's both degree 2. When they're both degree 2, in 30-1, we will get an asymptote for both asymptotes and a point of discontinuity when they're both degree 2, right? This here gets me my point of discontinuity. Because that x can't exist, because it's in the denominator, it can't exist. But because it cancels off, it's a point of discontinuity. Continuity. Discontinuity. Missing some words. Some letters in there. There's a tin that's missing. Anyways, we have x equals 2. How do we get the y? Plug 2 into the simplified version. So we put y equals 2 plus 3 over y equals 2 minus 4, which is 5 over -2. Okay. When they're both degree 2, I get a vertical asymptote as well. What's my vertical asymptote at? X equals what? What's my horizontal asymptote at? Yeah, because you took leading coefficients because it's both in one. There was one last version we went over. So we went over another one where the degree of the numerator is larger than the degree of the denominator, correct? So we have a degree 2 over a degree 1. So if we factored, it would be like x plus 3 over x minus 1, or x times, sorry, multiplied by x minus 1 over x plus 3. What happens here? There's no asymptote. We are going to get a point of discontinuity because of these, and then it's just a line with a point of discontinuity. A line at x minus 1 with an open dot, correct? So here we would get, often they're not in factored form, right? You would have to tell the factor. Point of discontinuity at -3 and something. And remember, solving for the y of the point of discontinuity is the standard of excellence in our curriculum. Oops. Thanks, board. So we would have a line at x minus 1, and then a point is constant. Correct? So these are all in full something over full something. It's just a fraction. That's what these are. These are all like y equals a fraction. We agree? When they're in y equals a fraction, we use the three rules. Okay? But they can also be in transformed form. Equations if you're solving for x, functions if we're just looking at it, and then we go transform. Transformed form is y equals a b x minus c plus d. Where you don't have a full fraction. You end up with your vertical stretch, your reflections, your horizontal stretch, your translations, all of the jazz. So your parent function, and we talked about the parent of a radical is y equals square root x. The parent function of a rational is y equals 1 over x. And type y equals 1 over x into your calculator. Now, this is awful. Do not draw graphs like this. It will be like this and like this. This is how I get graphs drawn on a test. Did I even plot a point? No, I just went, it looks kind of like this. Is that a good graph? Would that get me any marks? No. It also doesn't have my asymptotes on it. I'm drawing too fast. I'm not drawing dashed lines. But I would have to go to my calculator and pull some points off, correct? Like this is not an accurate graph whatsoever. The only thing that's accurate is the asymptotes, and one of them has a straight line because I drew too fast. It should be dashed, showing that it doesn't exist there. Now, what I really wanted you to see here is the parent function of a graph, of a rational, exists in quadrants 1 and 3, right? But any reflection would cause it to go to 2 and 4. What if I gave you both reflections? What if I made you reflect in the x and the y? It would just go back to where it once was, right? It would be back to 1 and 3. So that's something we need to think about. Okay, what if I give you this? So my domain of this would still be x can equal 0, y can equal 0, right? That's the same as it was before. But say I give you this. What can move asymptotes? We had asymptotes in exponentials and in logs. What can move asymptotes? Yeah.
Vertical and horizontal translation.
Right. So exponentials, vertical translations moved it, right? Logs, horizontal translation moved it because they had a vertical asymptote, right? Vertical asymptote just moved to the horizontal translation because it's an x equals asymptote. Horizontal asymptotes moved by vertical translations. We agree? So what do you suppose, because this is in transformed form, I have A, I don't have a B right now, C, D. What do you think, without having to do any math, and we aren't using any rules right now, right? This is transformed form. Because it's not a full fraction over full fraction. Full fraction over full fraction, we can use the rules that we learned, correct? This is not a full fraction. This is just using transformation laws. So what would my vertical asymptote... No, board. What would my vertical asymptote be at? So visualize, vertical asymptote. X equals 0, right? Yep.
That's x equals 3.
And x equals 3. It still follows the same rule. It's still where your non-permissible values can't be, right? It's still your NPV. So that one doesn't change. But where's my horizontal asymptote this time? Now I'm not looking for rules. I'm not looking for degree of numerator, degree of denominator, none of that stuff, because it's not a full fraction over a full fraction. This is transformed form. So what is my horizontal asymptote going to be at this one? Y equals 2, because the only thing that can move it is a vertical translation, correct? It's normally at y equals 0. It's now been moved 2 up. We agree? So it's y equals 2. So when we're in transformed form, your vertical asymptote comes from here, and your horizontal asymptote comes from here. Because it's the movement. It's moving that asymptote, the vertical asymptote 3 to the right. Moving that horizontal asymptote 2 up, right? So it's kind of like moving an exponential analog asymptote. It's kind of what we're doing when it's irrational. Which I know it's not a log and exponential, but you know what I mean. Okay? Now if we state our transformations, we have a vertical stretch, by a factor of what? 4 about the x-axis. We have a no horizontal stretch, we have no reflections, and we have a vertical translation to up and a horizontal translation to right. The mapping and words are the same, so xy becomes x plus 3 to move it 3 to the right, and then 4y plus 2. All fine and dandy if I give you numbers. Because people could even, if they forget, brains fall out of their heads, they can put it in their calculator and look at it, right? Remember that if I give you variables, though, I have to state what the variables at the very least are. If I don't state anything about them, then they kind of, I have to give you information that would lead you to what that one could be. So say I give you this. Basically, they're just numbers. Greater than 0, right? 2, 7, 9, 1.5, 3, 8.7692. Use that. I wouldn't suggest it, but use that. I want the vertical asymptote. I want the horizontal asymptote. I want the transformations. What's the very first thing whenever I give you anything in transformations? What do you have to make sure? X is a 1 in front before you do anything, right? So if I take that negative n out, I'm dividing it. We agree? So what am I going to be left with? X minus what?
T over n.
T over n. Trust me. So we know our vertical asymptote. Why did it go off the mark? We know our vertical asymptote is x equals what?
T over
T over n, yeah. And then our horizontal asymptote k down. So my horizontal asymptote, instead of being at y equals 0, is going to be at y equals negative k. So I say to you all the time that you have to know your rules really well, and you have to understand the question really well, because they throw variables in, and then your plugging in skills get a little bit lower. But can you not plug in numbers and try and reason your way through? If you do, please write m equals 3. Like, write it down for yourself so you know like what the numbers are that you put in, and don't put any of the same ones. Don't be like m equals 3, n equals 3, t equals 3, k equals 3. Like, don't do that. Okay? If you are plugging in for your unknowns, make sure you say what they are. So my domain then is x such that x can't equal t over n, x the now of the reals, or in interval notation, it'd be from negative infinity to t over n, or t over n to positive infinity. Basically everything but t over n. And then my range is everything but negative k. So it's y such that y can't equal negative k, but y is everything else. And in interval notation again, negative infinity to negative k, or k negative k to infinity, round brackets. Now my transformations, there's so many. There's a reflection on both, right? So my graph's going to end up in 1 and 3 again. We agree? Because they can sometimes ask you which quadrants it ends up in on these variable ones too. And you know that if it reflects in both, it's going to be back to 1 and 3. If it reflects in either or, it's going to be 2 and 4, right? Because it'll make it go like this, or it'll make it go like this, just move it into different quadrants. But if it reflects in both, it'll go boom, and then boom. It'll go right back to where it was. So here we have a vertical asymptote. Wow, stretch. Just get rid of the A. Stretch by a factor of what? M. About the. Do we have a horizontal stretch? Yeah, we have a horizontal stretch. By a factor of 1 over n about the y-axis. Oh my gosh, it's lagging so bad, I need to restart it. Reflection on the x and y-axis. One thing you can write together. Vertical translation. I forgot the word units last time. Translation. K units down. And a horizontal translation. Oh my gosh, it's so slow. T over n units. So then we have x, y becomes negative 1 over n x plus p over n, comma, negative m y minus k, if that isn't confusing at its finest. We have one little thing that I want to show you later, but I'm not going to do it right now because I just don't know all those people. So this is a formula that you'll use. You can use this to find the equation of a rational if the rational just has a vertical and horizontal asymptote, right? You put your vertical asymptote in the bottom, your horizontal asymptote in the K spot, or D, and then you solve for A using a point. That's it. So if you don't have a point of discontinuity, this is your best bet. Easiest way to get an equation. Okay, so I'm going to throw numerous ones at you on Friday and see how you do with them. Okay. On next week, Mondays, when we start limits. And your homework for this is section 9.1. So right over here, it doesn't fight me as much. So just an FYI, remembering that I'm going to write these down, and I'm checking homework every day from now until May 30th. Every day, I'm checking it. Remember, if you don't have homework done that day, I'm going to put you in as a 0, right, as a not handed in, and then it's your job to come show it to me after that day if you want it to not be an NH, right? So if you don't finish your homework, I'm checking on the one day. If you're not done it, it's your job to come show it to me after that. Because your homework is either a 0, sorry, not a 0. It's an NHI or a 1. When you hand it in, you get a 1. When you don't have it handed in, it's an NHI. That's it. All there is. So some people might say, but Mrs. Lepp, I have work tonight. Correct. So tomorrow yours will go in as an NHI, and you'll finish it the next day, and then your job is to come bring it to me, and I put it in. Correct? Make sense? So, if you have homework tonight, I don't want you to stay up till 3 in the morning doing these questions. That is not what I want. Tomorrow you will go in as NHI, it might hurt your heart for a little bit. Don't worry, I don't put the question marks in there. It won't hurt your heart at all. And then we'll put it in. Get it? Got it? Yeah?